Hello everyone, welcome to this session. I am Dr. Sharmila, Assistant Professor, Department of ECE, Krishna Engineering College. So in this Electronics Engineering lecture series, in this third lecture, you are going to see about types of semiconductor. So the learning outcome of this video is you are going to learn types of semiconductor materials. There are two types of semiconductors material, intrinsic and extrinsic semiconductor materials. So before we go into the today lecture, I am just going to revise the topics which we discussed in the previous lectures. So in the previous lectures, I gave introductions about the semiconductor material. You know the different types of material. Generally, there are three types of material based on the electrical property, such as conductors, insulator, and semiconductor material. In the electronics engineering subjects, you are going to learn about the semiconductor material. So you know what is a semiconductor material? In semiconductor material, its conductivity level is in between conductor and insulator. So you know the best examples of semiconductor such as silicon, germanium, gallium arsenide, etc. So then we saw about the properties of semiconductor. So one of the important properties of semiconductor is negative temperature resistance. So the negative temperature resistance is defined as the temperature is inversely proportional to the resistance value. At 0 degree Kelvin, the semiconductor is act as the insulator. When the temperature is increases, the conductivity of the semiconductor also will increase. So when the temperature is increases, the semiconductor is act as the conductor. So in this today topics, we are going to see about different types of semiconductors. So types of semiconductors. There are two types of semiconductors. First one is intrinsic semiconductor and extrinsic semiconductor. This extrinsic semiconductor is further classified into P-type semiconductor and N-type semiconductor. So first we are going to see about the intrinsic semiconductor. This intrinsic semiconductor is also called as the pure form of semiconductor. So what is the meaning of pure form is the semiconductor is extremely in the pure form without adding any impurities. So you know the examples of semiconductor, that is silicons and germanium. So we are going to use either silicon or germanium to construct the electronic device. Okay. So intrinsic semiconductor means it is a pure form of semiconductor. Okay. So what is the meaning of extrinsic semiconductor is it is an impure form of semiconductor. What is the meaning of impure is we are going to add some impurities in the semiconductor material. So that is the extrinsic semiconductor or impure form. So the process of adding impurities in the semiconductor material is called as a doping. So first we are going to see about intrinsic semiconductor. It is also called as the pure form. Okay. So here I taken the examples of silicon crystal structure. Already in the last lecture, I explained you what is crystal structure. So I will repeat the same again. So crystal structure means when the atoms are combined to form a solid, that is a crystal structure. Okay. In this crystal structure, I am considering a silicon element. Okay. For the silicon, you know that for any semiconductor material, it has the 4 valence electron in the outermost shell. Okay. So here in the intrinsic semiconductor is the pure form of semiconductor. Here I am not going to add any impurities. Okay. Simply I am considering only the silicon material. Okay. When the temperature is 0 degree Kelvin, okay, that time the semiconductor is act as the insulator. Insulator means what? The material which does not conduct. Okay. The conductivity is very low and the resistivity is very high. At the 0 degree Kelvin, the semiconductor is act as an insulator. When the temperature is increased above 0 degree, what will happen? Let me see. Okay. So this is the crystal structure of the silicon. Here, in this crystal structure, any material which has the more number of silicon atom, in this semiconductor material, it has the more number of silicon atoms. Each and every silicon atom tries to get 8 valence electron. Already the silicon atom has 4 valence electron in the outermost shell. So it is trying to get another 4 electron from the neighboring silicon atom. Okay. So the sharing of, that is just to see these two silicon atoms. In these two silicon atoms are associated. Okay. This association is called as the covalent bond. What is the meaning of covalent bond? These two silicon atoms are going to share the electrons. Okay. So sharing of electron is called as the covalent bond. So here this blue line, that is, these association represent the covalent bond between the two silicon atoms. So these two atoms are sharing an electron. Okay. When the temperature is increases above 0 degree, what will happen? The electrons in this covalent bond get an energy and break the covalent bond. Okay. This blue color is the covalent bond. When the temperature is increases above 0 degree, the atoms in this valence band, that is atoms in this covalent band, get an enough energy and break the covalent band. Okay. Once it break the covalent bond, it goes to the conduction band. Okay. So here you see, okay, when the temperature increases, the electron in this place get an enough energy and break the covalent bond. It moves to the conduction band. Okay. The electrons moves out of this valence band is called as the free electron. Okay. So that is called as the free electron. Okay. So the electron departed from the place, it is called as the hole. The electron departed from this place is called as the hole. Similarly, you consider this silicon atom. This silicon atom, the electron in this covalent bond electrons in this covalent bond get an enough energy and break the covalent bond. So the electron is depart from this place. Okay. So that is, it forms a hole. Now this free electrons will move towards this hole and fill this gap. Okay. This whole gap, vacant place is nothing but a hole. This free electrons will move and fill this gap. Okay. So why I am explaining this concept is, in the intrinsic semiconductor material, the number of holes is equal to number of electron. Okay. At the given temperature, the number of holes is equal to the number of electrons in the intrinsic semiconductor. Whenever the electrons moves out of the covalent bond, that gap is, that vacant place is filled by the electron from the neighboring atoms. So the number of holes is equal to the number of electrons. So there is no movement of free electron in the intrinsic semiconductor. If there is no movement of free electron, means there is no current flow also. When the temperature is increases above 0 degrees Celsius, at the given temperature, the number of holes is equal to the number of electrons. Okay. So you know the value of 1 electron volt, that is 1.6 into 10 to the power minus 19 joules. So the main thing about the intrinsic semiconductor is, it is the pure form of semiconductor. Pure form means we are going to use either silicon or germanium. At the 0 degree Kelvin, the semiconductor materials act as the insulator. When the temperature increases, the electron in this valence shell get an enough energy and break the covalent bond and moves to the conduction band. Okay. The movement of that electron is called as the free electron. Whenever that is when the electron depart from this place, it create one hole. This hole is filled by the electron from the other atoms. So in the intrinsic semiconductor, the number of holes is equal to the number of electrons. So next one is the extrinsic semiconductor. The extrinsic semiconductor is also called as the impure form of semiconductor. Why we are going for the extrinsic semiconductor is, in order to in order to create a more number of electrons and holes in the material, we are going for extrinsic semiconductor. It is also called as the impure form. In the intrinsic semiconductor, the number of holes is equal to number of electrons. So the holes and electrons are neutralized each other. But in the extrinsic semiconductor, in order to increase the conductivity, we are going to add some impurities to the intrinsic semiconductor. Intrinsic semiconductor means pure form. In the pure semiconductor, we are going to add some impurities. Okay. So that is called as the extrinsic type semiconductor. in order to increase the conductivity of the intrinsic semiconductor, we are going to add some impurities to the intrinsic semiconductor. The resultant material is called as the extrinsic type of semiconductor. So what is the meaning of doping? Sometimes they will ask in a 2-mark question also. So doping is a process of adding impurities to the intrinsic semiconductor material. So what is the meaning of doping? The doping is a process in which the impurities is added to the pure semiconductor material. Pure semiconductor means what? That is the intrinsic semiconductor material. Okay. So next we are going to see about types of extrinsic semiconductor. There are 2 types of extrinsic semiconductor. One is p-type semiconductor. Second one is n-type semiconductor. Okay. So what is the meaning of p-type semiconductor? So p-type semiconductors is formed by adding the trivalent impurities in the intrinsic semiconductor. Okay. So what is the meaning of p-type semiconductor? The p-type semiconductor means we are going to add trivalent impurities. What is the meaning of trivalent? Trivalent means the silicon, that is the any atom, it has 3 valence electron in the outermost shell. So what is the meaning of tri? Tri means 3. So any atoms or any element which has 3 valence electron in the outermost shell, that atoms we are going to add with the intrinsic semiconductor. So what types of impurities we are going to add? We are going to add trivalent impurity. So the examples for trivalent impurities are boron, aluminum, gallium, etc. So these materials we are going to add with intrinsic semiconductor material. In the trivalent impurity, if you are adding into the intrinsic semiconductor material, it generates the excessive holes. Okay. In the n-type semiconductor material, we are going to add pentavalent. What is the meaning of penta? Penta means 5. Okay. What is the meaning of penta? Penta means 5. So what is the meaning of pentaatom is? So any atom which has 5 valence electron in the outermost shell, that is the pentavalent atom. So in the n-type semiconductor material, the pentavalent atom is added to the intrinsic semiconductor material. It generates excessive holes. In the p-type material, the majority carrier is holes. In the n-type material, the majority carrier is of electrons. So first we are going to see in detail about the p-type intrinsic semiconductor material. So what is the meaning of p-type extrinsic semiconductor material? The p-type semiconductor material means we are going to add trivalent impurities to the intrinsic semiconductor material. So examples for trivalent is aluminum, boron and gallium. What is the meaning of trivalent? Trivalent means the atom which has 3 valence electron in the outermost shell. That is the trivalent. Okay. So the examples for trivalent is boron, gallium and arsenide. Okay. Boron, gallium, aluminum, etc. So in the p-type extrinsic semiconductor material, I am going to explain with the help of crystal structure. In this crystal structure, here I am considering a aluminum impurities. That is, I am adding the aluminum impurities with the intrinsic. Intrinsic means what? Pure form of semiconductor. Here I am considering a pure form as a silicon material. Okay, either you can consider silicon or germanium because these two are popularly used in the electronics industry. So in this p-type extrinsic semiconductor material, I am going to add aluminum impurities with the silicon material. Okay. So already I told you that if it is of p-type semiconductor material means the impurities which has the 3 valence electron in the outermost shell. So this aluminum has the 3 valence electron in the outermost shell. The one electron is, that is one is a vacant. Okay. That vacant is nothing but a hole. Okay. So the one vacancy is created in the aluminum. Okay. So you know that crystal structure, the atoms are combined to form a solid. Okay. So here in this aluminum atom, the 3 electrons are associated with the neighboring silicon atom. So here you see this silicon atom, first one, second one, third one. So in this aluminum, these 3 valence electrons are associated with this 3 silicon atom. That one place is vacant. That is nothing but it is unassociated with this silicon atom. So the trivalent shares the 3 electrons with the neighboring atom. One vacancy remains in the outermost shell. Okay, so that vacancy means what? The vacancy is nothing but the holes in the structure. Okay, so there is one hole in the structure. So every trivalent, that is every trivalent atom, for example, here I am considering aluminum. So it creates a one hole. Okay, that means the p-type extrinsic semiconductor material creates a more number of holes in the semiconductor material. Okay, so that's why it is called as this trivalent atom is called as the acceptor atoms. Okay, so in the p-type extrinsic semiconductor, what is the important point you have to keep it in your mind? So first point is the impurity. What types of impurity atom we are going to add with the semiconductor material is trivalent atom. Trivalent means the atom which has the 3 valence electron in the outermost shell. So each electron is associated with the silicon. That means only these 3 electrons only associated with the silicon, 3 neighboring silicon atom. So one is free. The free place is nothing but a vacancy. It is called as the hole. Okay. So every trivalent atoms create a one hole. Okay. So this hole is nothing but a acceptor. Why it is called as an acceptor is, so here you consider this neighboring atom, neighboring silicon atom. This silicon atom get an enough energy. When the temperature is increases, this silicon atom, that is electron in this covalent bond, get an enough energy and break the covalent bond, and it will move out of this covalent bond. Okay, that is called as the free electron. This free electron will go moves and fill this place. Okay, so here similarly, if this electron will moves to this hole, means here there is one vacant is created. Okay, that means here one hole is created. So in this way, in this p-type extrinsic semiconductor material, the more number of holes are created, that holes are act as a acceptor. What is the meaning of accept? Accept means you are going to accept something, right? So each and every hole is going to accept the free electron. So that's why it is called as the acceptor ion. So important thing, in the p-type extrinsic semiconductor, what is the majority carrier? Here the majority carrier is hole, and then the minority is nothing but here the minority carrier particle is an electron, and we are considering the acceptor ion. This trivalent atom is called as the acceptor ion. Acceptor ion means the each and every atoms create a hole. That hole is filled by the electron from the neighboring atoms. Okay, so that's why it is called as the acceptor ion. Okay, so next we are going to see about N-type. Before that, in P-type you have to know the number of holes is greater than the number of electron in the p-type extrinsic semiconductor material. So next one is N-type extrinsic semiconductor material. Already I told you that N-type extrinsic semiconductor material, you have to consider the pentavalent atom. So the pentavalent atom is nothing but this types of impurity. What is the meaning of pentavalent? Pentavalent means the outermost shell consists of 5 valence electron. These types of pentavalent atom is added with the intrinsic. Intrinsic means what? Pure semiconductor material. Okay, here the impurity material is, it should be of pentavalent atom. Pentavalent means what? The valence shell, it should consist of the 5 valence electron. So the examples of the pentavalent atoms are arsenic, antimony, phosphorus, etc. Okay. So what is the meaning of N-type extrinsic semiconductor material? So we are going to add 5 elements are in the outermost shell of the impurities. Okay. The element which has 5 valence electron, that element we are going to add with the pure semiconductor material. So out of 5 electrons, the 4 electrons are shared with silicon. Okay. Here you consider this crystal structure. In this crystal structure, I am considering a phosphorus impurity atoms. So this phosphorus has 5 valence electron in the outermost shell. What we are going to do exactly? We are going to add this phosphorus impurities with silicon material. Okay, you know that for the silicon material, it has the only 4 valence electron, but the phosphorus has 5 valence electron. So out of 5 valence electron, only these 4 electrons only associated with the silicon atoms. Okay, so these 4 electrons only going to associated with the neighboring silicon atom and create a covalent bond. Covalent bond means what? Sharing of electrons. Okay, so it has one extra electron. Okay, that one electron is not associated with the any silicon atom. That electron is act as the free electron. So in this N-type extrinsic semiconductor material, so the number of electrons is more than the number of holes. But in P-type extrinsic semiconductor material, the number of holes is more than the number of electron. But in case of N-type extrinsic semiconductor material, it has a more number of electron. Okay. So in the N-type extrinsic semiconductor material, the majority carrier is of an electron and minority carrier is of a hole. Okay, so here I just gave a simple diagram. So from this material you can comes to know. So N-type semiconductor material, the majority carrier is of an electron. You know that electron is of a negative charge particle. Okay, so negative. So the minority charge carriers are holes, that is nothing but their plus here. Holes are a positive charge particle. Okay, here it is of a, the atoms are called as the donor ion. Why it is called as the donor is, it is donating the more number of electron, but in case of P type, it has a hole, that hole accept the electron from the neighboring atom. But in case of N-type extrinsic semiconductor material, it has a more number of electron. The electron is act as a that is, the electron is donating to the neighboring atom. Okay, so it produces a more number of free electron. So the N-type semiconductor material, main thing is pentavalent atoms we are going to add with the pure semiconductor material. Pentavalent means the atom should have 5 valence electron in the outermost shell. Okay, so out of 5, only 4 is going to associated with the neighboring silicon atom. So one is left free. Okay, so in this N-type extrinsic semiconductor material, the majority carrier is an electron, minority carrier is the hole. It has the donor ion. Okay, so in this lecture, within this, the lecture is over. Here I gave the learning by doing activities. You have to attend these 3 questions. The knowledge from the knowledge which you gain from this lecture, you are going to attend this. Just to pause the video and try to answer for these questions. Okay. Okay, I hope now you have answered these questions. So now I will discuss with you. So intrinsic semiconductors are those. What is the meaning of intrinsic semiconductor material? So which are made up of semiconductor material in purest form, or there is zero energy gap, or which has no more electron than the hole, which is available locally. So the correct answer is the intrinsic semiconductors are the material that is made up of the it is in the purest form. Okay, so intrinsic semiconductor material of the made up of the semiconductor material in its purest form. So the answer A is the correct option. So second question is, the pure semiconductor behave like the insulator at 0 degree Kelvin. Why? So I already told you that at 0 degree Kelvin, the semiconductor is behave like the insulator. The reason is the free electrons are not available for the current conduction. So already I explained you the concept of effect of temperature on a semiconductor material. When the temperature increases above 0 degree Kelvin, the electrons, that is, when the temperature increases above 0 degree Kelvin, then only the electrons in the valence shell get enough energy to break the covalent bond and moves to the conduction band. Okay, the electrons moves out of the valence band is called as the free electron. So in at the 0 degree Kelvin, there will be no free electrons available for the conduction. in semiconductor material, the conduction is depends on the number of free electrons. So answer is C. That is, the free electrons are not available for the current conduction. When the temperature increases, then only the current flow will also increase. Okay, that is the concept of negative temperature coefficients. Already we saw. Third one is a p-type semiconductor results when. What is the meaning of p-type and n-type semiconductor? You know, so the p-type semiconductor results when means what? In the p-type semiconductor, the trivalent impurities is added to the intrinsic semiconductor. In n-type only, we are going to add pentavalent impurity. So we are not going for either pentavalent or trivalent. If it is of p-type semiconductor, we are going to add trivalent impurity added to the intrinsic semiconductor material. So I hope you have understood about what are the different types of semiconductor materials. Okay. So thank you. We will see in the next lecture.